Okay, so hello, good morning, ladies and gentlemen. Good morning. If you're able to get me, please type yes. We get started. We are behind time. If you're able to get me, please type yes so that we get started. Okay, if you're able to get me, please type yes so that we get started. Okay, so I can see that you're getting loud and clear. I'm sorry for this technical hiccup that we had. You must understand that all of us are not having it easy, with all these challenges here and there. Nevertheless, we we get started. Before we get started, I think there are certain things that I would request of you. Please, I would, I think let us stop not typing these. I know that you are getting me, and if the volume is not okay for you, maybe try to add if okay. So as we had agreed last time, we are going to spend the first 10 to 15 minutes just trying to revise on what we had done last time. I think there are certain things that people said that we are not very clear. Okay, so specifically on, I think starting from basic and derived units, I will not go over everything, but I'll just quickly take you through, and then I'll also give you those exercises that we do just to ensure that you guys are on it. So we say that basic quantities, they represent in under mechanics, basic quantities represent the dimensions of length, which in SI units is measured in meters, mass, which in SI units is measured in kilograms, as well as time. Okay, so these are what are called basic units. Now, derived units are a combination of these basic units, and if you know, the easiest way is to derive them from a formula. If you know the formula, then you can, the formula will always be a combination of these basic units. So for instance, velocity is equal to distance over time. We know that formula. So distance is a basic quantity, so it is measured in meters, and then time is also a basic quantity. It is measured in seconds. So when you combine those, then you get the derived unit. Okay, I think I did also explain about density. You know that the derived unit for density will be kg per meter per cubic meter, because you know that mass is measured in kilograms in SI units, um, and then volume is measured in cubic meters. Okay, so I think I have a small exercise for you just to see how best you have understood this concept. I'm going to give it right away. Just as usual, I'm going to post it in your group. So just be ready so that we see how best this concept was understood. Okay. So just now I'm posting it in your group. So just be ready. Okay, so now I'm posting it in your group. Just in your groups, be ready for it. Okay, so just quickly go through it and see how you answer that. Okay, so let us give ourselves 3 minutes Let us give ourselves 3 minutes for this exercise. Okay, so I have posted the activity in your groups. I'm waiting for the feedback. I think we gave ourselves 3 minutes. 1 minute has already elapsed. Okay, so this is how our results look. This is how our results look. I think we have about 212 students, and then this is the distribution. So I can see on this side that I think a lot of students have scored very highly in this, and I think the topmost student was this Alan Msonda. Okay, so now let us just try to maybe go through together so that we see how you are supposed to answer this exercise. We go through together so that you see how you are supposed to answer this exercise. Okay, so let us just wait so that it loads. Okay, so here we are supposed to group these. You know, we have all these quantities here that have been given, and then we are supposed to categorize them, whether they are basic quantities or indeed derived quantities. Okay, so we say that basically we have three basic quantities that corresponds to mass. You know, is a basic quantity. You also know that time is a basic, because you cannot combine it. In mechanics, you cannot combine time with anything else. Is also a basic quantity. Now you know that distance. If you look at distance here, distance is basically a length. So this length. So you can categorize it under basic quantities. Look at height. Height is a length. Height is a length. So you can categorize it under basic quantities. Okay, and then what about when we talk about duration? Duration is nothing but a time. So it is time is always a basic quantity. Okay, and then what else is remaining? Now you see that if you look at all this volume, okay, is volume a basic quantity? You find that volume is a combination of quantities. What about weight? Weight is a combination of quantities and so on. So basically, this is what you are supposed to do in this exercise. Okay, so now okay, so now let us move to another concepts. I think on another concept on equations, units and equations. I will not say much here. What we are just trying to demonstrate, which I explained at length in the last lecture, is that if you have an equation, you must make sure that the units of that equation are the same on both sides. So if you have an equation where the units are not consistent, then that equation is not a correct one. Okay, so maybe the other thing that I just want to highlight is the issue of the order of magnitude. So because I received a lot of questions about the order of magnitude, so I would want to just go through again. So what did we say about order of magnitude? Okay, I'm just trying to see if I can write something, but unfortunately this thing will not allow me. Okay, so if you want to express the order of magnitude of a certain quantity, the key point is here to say that the order of magnitude estimation is made by rounding off all numbers in a calculation to one significant figure along with a power of 10. So the main issue here is with the power of 10. Okay, so you know the power that is associated to 10 here is what you actually call the order of magnitude. The power that is associated with 10 here is what you call the order of magnitude. So let me just try to give you some examples. Okay, so for instance, if we say that what is the what? If we say that what is the width of a football pitch, let us say the length of a football pitch, you know that it is 100. It is 100 meters for a football pitch. You have 100 meters. So how can you express this in a scientific notation? I think I taught you how to express things in scientific notation. You can just write it as okay, you can just write it as 1.0 times 10 to the power 2 meters. So what we are saying is that this 2 that is here is what is called the order of magnitude. This is the order of magnitude. This is what is called the order of magnitude. Okay, let me just go to the comments just to see what is happening there. Okay, let me just go to the comments to see what is happening under the comments. Okay, so you couldn't see. I think I'm sorry for that. I'm going to repeat what I just did because I think I put a wrong screen. Okay, so I'm going to repeat. Don't worry. Okay. All right. So I think let me just go through what I was trying to explain on order of magnitude. I think now I'll put the correct screen. So we are saying that order of magnitude is just a way of doing a rapid estimation of something. Order of magnitude is just a way of doing a rapid estimation of something. And then the key word here is to express something in scientific notation. So if you express something in scientific notation, the power is actually what is called the order of magnitude. Okay, so here I was here. That is now where I explained. So for instance, if you say that the length of a football pitch is 100 meters, then you can express this 100 meters in scientific notation as 1.0 times 10 to the power 2 meters. So the order of magnitude here is 10 to the power 2 is actually the order of magnitude. That is what is referred to as the order of magnitude. Okay, so I think we are going to move. Okay, so the other issue okay, so now the final thing that we discussed in the last lecture was about dimensions and the dimensional analysis. Dimensions and the dimensional analysis. Now, in order for us to understand the dimensions, maybe let us start from units. What are units? We had mentioned that, for instance, we said that in the SI system of units, length is measured in meters. In the SI system of units, length is measured in meters. Now, you know that it can also be measured in centimeters. It can also be measured in kilometers. It can be measured in any units. Only that by convention, the SI system chooses the meters. Are we together? Now, what is the nature of this unit? What is the nature of the unit, which are meters? The nature is that it is a length. So, the dimensions, the meters have got dimensions of length. It means that any quantity which you express in meters, it means that it should be a length in nature. And in the same way, any units that you express in kilograms in the SI system of units, then the nature of that units that we refer to as the dimension is a mass. So when we are doing dimensional analysis, we put these square brackets here to signify the fact that what you are doing is a dimension. Are we together? So I think also let me give you another exercise on dimensional analysis, because here I think I received a lot of queries, which meant that the students didn't understand. So I have an exercise on dimensional analysis where we are just going to do something. Okay. So just wait for the link. Just wait for the link. In 10 seconds, I'll be able to send that in your groups, and let us try to do it as quickly as possible. Okay, so we have 3 minutes in which to do that activity. We have 3 minutes in which to do that activity. Okay, we have 3 minutes in which to do that activity. Okay, so I think we have used up all the time. Okay, so now let us look at how we have done, how we have fared. We have a total of 336 students, and then the average mark out of 6 is 4.8, which is not very bad. It means that at least people have understood. And then 170 students got everything correct. The one who did it the fastest is Michael. Please put your surname. I would be interested in also the surname. Okay, so let us try to do the activity together in the interest of those who didn't manage to get it right. Okay, because this is what is leading to dimensions. If you understand the units, then it will be very easy for you to understand the dimensions, what dimensions mean. Okay, so now let us try to do this. Okay, so here we have on this side, you can see that we have some quantities, so which we must match with the units. Okay, we have quantities that we must match with the units. So let us start with this one. Okay, so we start with this one. Okay, maybe let us start with this one, the distance from Kabwe to Lusaka. So the distance from Kabwe, since it is a distance, you know that you must measure it in the SI units. You must measure it in units over. So you can put it there. You can either put it here or put it here, wherever you want. These are all the same. Okay, so the other thing that you might want is the duration of the PHY 101 lecture. This is a time. A time. So what units is it be measured? So we are just trying to match these quantities with their corresponding units. Okay. What about the speed of a car? You know that the speed of the car is measured in meters per second. Speed is just how much distance has been covered per unit time. You know that you can use that formula for speed. Speed is equal to distance over time. So the distance is measured in meters, the time is measured in seconds. You can put it there, and so on and so forth. So until you submit. Okay. So now from this exercise of the units, now let us go to dimensions and see how the dimensions work. You see, so what you do is that if you see that speed, for instance, speed has got dimension units of meters per second, then you ask yourself, this meters, what is the nature of the dimensions of the meters? This meter is basically a length. So you are going to say you put those square the square brackets, and then inside you put L, which means that this meter here, it has got dimensions of length. And then seconds, what are the dimensions of seconds? Seconds is a time. So you use capital letter T, and then you enclose those square brackets. Okay, so let us try out this activity now on dimensions. We see if we are going to get it right. Let us try this activity on dimensions so that we see whether we are going to have it. All right. Very soon I'm going to send. Very soon I'm sending a. Okay, so I'm now sending to your groups so that you try. We give ourselves 4 more minutes for that. Okay, so 4 minutes. Okay, so I think we have used up all our time. We have used up all our time, and I think this is what we have. Maybe let me just refresh it one more time. Okay, so I think from this one, I think people didn't do very, very well. I think the average score, the average score isn't very bad. It is 4.5 out of 6. It means that in general, people did quite well. But then 131, only 131 students out of this 277 got everything correct. The first test in this case was the Namatama Mioba. Okay, so well, let us try to go through together this exercise. Let us try to go through together. Okay, so the exercise is here. The exercise here on dimensions. Okay, so it's quite similar to the one that we had for unit C, but then we want to express it in terms of dimensions. So I'll start with the simplest. You know that the simplest here are the basic dimensions. We say that we have 3 basic dimensions corresponding to time, time, which in SI units is measured in seconds, but then it can be measured in any other system of units that you please. But then in under dimensional analysis, we represent those dimensions by capital letter T. Okay, so amongst these, which one do you think have dimensions of time? Okay, of course, it will not be how heavy a pocket of cement is. It cannot be a distance. It cannot be a weight and so on. So the time here, the dimensions, you know that the duration of the physics lecture is the only thing we have, the dimensions of time. Are we together? So what are the dimensions? This is a time, so it means that the dimensions will be those of time. Let us go to the other one that is simplest. This the length. Okay. So amongst these, which one do you think has got the dimensions of length? I think I saw a question from a student under the comment section. It said, why is height a length? You know, if you have to measure height, in which units are you likely to measure it? Obviously, if you are working in SI units, then you'll be able to measure it in meters. Or if you want, depending on the convenience, you could measure it in centimeters. So it means that is basically a length. So height is actually the dimensions of height are length. I'm just going to drag and drop it here. Okay. And then which other one could have a length? You see that distance, if you talk about the distance from Kabwe to Lusaka, since it is a distance, then it has the dimensions of so I'm going to drag them here. Okay, now you see that these other ones, they have got combination. They are not basic quantities. They are actually derived quantities. So it means that even their dimensions will be in derived terms. So let us talk about the speed of a car. You know that the speed of the car is measured in meters a second. Speed of the car could be measured in meters per second. So meters, as we have already established, it is length. And then per second, it's so we're just going to drag there and put it there. All right. And then I think I've demonstrated to you how to do much of this. You can now try it on your own in your spare time. Okay. So now let us So at this particular point in time, I think this is where our lecture 1 was supposed to end. So what we have just been doing is to revise and try to try to consolidate the concepts that we had learned earlier. And at this point now, you allow me to go to the next lecture slide, which will be lecture slide 2. And then since we started late, we are not going to end at 11 as per our usual schedule. Maybe we can end at something like 11:30 so that we try to recover some of the time, because we are actually a little bit behind the time. So you allow me to just go and open the other slide. Okay, so now we are done with chapter 1, which was just basically about measurements and units. Now we come to chapter 2, where we are now going to get into the actual description of motion. In chapter 2, basically, we are describing motion. And in this lecture in particular, we are going to look at kinematics in one dimension. Very soon, we are going to know what kinematics mean. Okay, so a brief overview. I think I had done that. I had done this even in the previous lecture. How we are going to proceed. First of all, we are going to assume that the particles under consideration, the objects under consideration are point particles, meaning that their size is so small, it is concentrated in a certain point. So they are particles. In order for us to have, to simplify our lives, we are going to assume that the objects are particles. And at a later point, we are going to look at extended objects. So the other starting point that we are going to take is that we are going to consider only translational motion. Now, when something is moving, when an object is moving, there are a lot of motions that it could exhibit. One of which maybe could just be one of which could be translational motion, where the object is just moving from one point to the other without rotating. So when we talk about translational motion, we are just talking about pure translation from point A up to point B without any rotation. Now, if we come to rotational motion, then we also consider, as the particle is translating, it could also be rotating. It could be spinning around some axis and so on and so forth. So we'll come to that at some point. All right, and then at the end of the course, we are now going to go into what is called continuous media or extended media, where we are going to look at solids and fluids, and that will culminate into thermophysics. At this point, maybe let me just try to see the comments, the comments that are coming forth. Okay, just try to see the comments that are coming. So length is L is distance. I can't understand that comment. Maybe you can just write it again from Lindsay Ilunga. Is anyone else experiencing technical difficulties? Maybe try to check your connectivity, your internet connectivity, because I think so far things are okay. And then what is the next valid question that I can see? What is the next question that I can see? What is the difference between meters? No, there is no difference between meters dot and meters. There is no difference. It was just a representation. And sir, is temperature a dimension? Is temperature a dimension? So temperature is not a dimension. Temperature is not a dimension. in mechanics, we only talked about three basic dimensions, which are length, time, and mass. So temperature will not fall under that. So here, when the other question that I can say is, okay, I think it's like we have exhausted all the questions. We have exhausted all the questions. So for the units that you are seeing where one has got a dot, the other one doesn't have a dot, they are just one and the same thing. So don't bother yourself. It's one and the same thing. Okay. So let us go back to, okay, so this is just basically the outline of the topics that you can find in the book. I think for these slides, we are using the book by Douglas Giancoli. So this is the order of the topics. Okay, so this is the terminology that we are going to employ in this study of in the study of this course. So mechanics is simply the study of motion. Mechanics is basically the study of motion, and this study of motion can be broken down into two. The first branch is the kinematics, which is just a description of how motion occurs. So kinematics is simply a description of how motion occurs without regard to what causes the motion. On the other hand, so under kinematics, basically we will just talk about the three equations of motion and then how you can apply them in order to describe motion under various conditions. Okay, under dynamics, we are going to describe, okay, sorry, I think I need to go back to the other mode of presentation. Okay, so here what I was saying was that this is the terminology that we are going to use. Mechanics is defined as the study of motion. Okay, mechanics is broken down into two. It has got two parts. It has got kinematics, which is the description of how motion occurs. Basically, we are going to derive some equations that govern motion of objects, and we are going to see how to apply those equations. And then dynamics is the other branch of mechanics, which deals with basically why objects move. So under dynamics, basically the main concept that we introduce is the concept of force. We are going to see the concept of force that is within the framework of Newton's laws of motion. And I think much of this course is going to be concerned with dynamics, application of Newton's laws, and so on and so forth. Okay, so we start with the frames of reference. What do you understand by a frame of reference? What do you understand by a frame of reference? So every measurement must be made with respect to a frame of reference. For instance, let us look at this train. You can see that this train is moving to the right. We are saying that the train is moving at a speed of 80 kilometers per hour. The train is moving to the right at a speed of 80 kilometers per hour. Now, this 80 kilometers per hour, in physics, we don't just say 80 kilometers per hour. It must be with respect to what frame of reference. Okay, so someone who is standing by the rail station, not inside the train, is the one who is going to measure this 80 kilometers per hour. So we say that the train is moving at a speed of 80 kilometers per hour with reference to the ground. What it means is that someone who is standing on the ground, who is in the earth frame of reference, is going to observe that 80 kilometers per hour. Okay, but then look at someone who is inside the train. Inside the train, we have a person who is moving to the front. Okay, now this person is moving, the motion is taking place inside the train. So this person is moving at a speed of 5 kilometers per hour. With respect to what? With respect to the train. If you want, you can say that with respect to the flow of the train. So what it means is that, for instance, this guy here who is at the back of the train, when he looks at this person, he's going to observe a speed of 5 kilometers per hour. Now, this guy, imagine that there is someone who is standing by the train station on the ground and looking at this same person. That person will not observe 5 kilometers per hour. This person is going to observe this guy as moving at a speed of 8 kilometers per hour, which is the speed of the train itself, plus the speed of this person, which is 5 kilometers per hour. So the person who is standing on the ground is going to observe a speed of 85 kilometers per hour. Okay, so we have from this slide, what we have established is that the motion of the same object, this object, when viewed from the train, is 5 kilometers per hour, but when viewed from outside the train, the speed of this object is 85 kilometers per hour. So the point, what is the takeaway? The takeaway here is that motion is not relative. Motion is not relative. In particular, speed is not relative. It depends on where you are observing that motion. So where you are observing that motion is what is called the frame of reference. Which frame of reference are you observing that motion? Okay, so that explained. With that explained, we are saying that when specifying speed, you must always specify the frame of reference which you are using. When describing speed, you must always specify the frame of reference with which you are using. Of course, there are times when it is very obvious. When, for instance, the car is moving at 100 kilometers per hour, but the train is moving at 60 kilometers per hour without specifying the frame of reference. In that particular case, we are assuming that it is obvious that we are measuring with respect to the earth, with respect to the ground. Okay, so when specifying velocity, you know that there is a difference between speed and velocity, and there is also a difference between distance and displacement. I think we are going to come to that. We are going to come to that in a moment. So when specifying vector quantities, then you must always specify the direction. And how do you specify the direction? We make use of a coordinate system. You must introduce a coordinate system. Okay, so before I talk about the coordinate system, let me go to the section for the comments so that we see what is happening there. Let us go to the section for the comments. Okay. Okay. So people, please, we have moved already. We are no longer talking about those exercises. Please let us be together. We can do those exercises at our own time. Now we are on this lecture slide number 2. Okay, so someone is saying kindly slow down. Yes, I'm trying my best to slow down, but to not spend the whole day just on one side because we have much to cover. I'll try my best to slow down. Okay, someone is saying, sir, repeat on what? You haven't specified what I should repeat. Okay, Shadrach Mumba, well explained. Thank you very much, Shadrach. Thank you very much. So someone is saying, finally, the real physics. Yes, now we have gotten into the real stuff. Someone, Mola Mavote, you are too fast. I'll try my best to slow down. Okay, so does the frame of reference only affect time and distance? That is from Mumba Chapa. So the frame of reference, it, basically, in other words, the frame of reference is the position, so to speak, where you are making the measurement from. So in that example that I gave about the train, you could make measurements from inside the train. So you can say that you are making the measurements from the train frame of reference. If you are making the measurements from the ground, you could make different observations of the speed and so on and so forth. So we say that you are making from the ground frame of reference. So with that explained, let me now go back to my slides and continue. So a coordinate system is, I think you are very familiar with it from your high school. No, it is just it constitutes of two axes. What is commonly known as the x-axis, and the other one, the vertical axis. The vertical axis is commonly referred to as the okay, let me repeat that. The horizontal axis, which is mostly referred to as the x-axis, and the vertical axis, which is commonly referred to as the y-axis. Okay, so the coordinate system is used to describe the position and the direction. The position and the direction. So how do you do that? So if you have a coordinate axis, then in order to describe the position of anything within this coordinate system, you need to have two pairs of coordinates. So for instance, maybe I think I'll really now need to write something. So let me escape from this presentation mode and okay, so if you have, for instance, I want to describe this point. I want to describe this point here. Within this, I want to describe this point. Maybe let me use a different color so that different from the, let me use that. So if I want to describe this point that is here, then basically what I need to do is to specify how many units do I have to move along the x-axis. It means that that will be my x-coordinate. How many units do I have to move along the x-axis? How many units do I have to move along the y-axis? So at the end of the day, I come up with a pair of numbers, which is called an xy coordinate pair. So let us summarize what we have said. Okay, so we are saying that. Okay, so okay, so what we are saying is that within a frame of reference, you can construct a convenient coordinate system. The coordinate system should have, first of all, a reference. What is the reference that you have taken? The reference point is what is called the origin. The reference point is what is called the origin. And then after you have constructed that coordinate system, then you say from the reference, how many units do you have to move along the x-axis? Then that becomes your x-coordinate. How many units do you have to move along the y-coordinate? That becomes your y-coordinate. And together, you are able to describe the position. Okay, so now let us come to displacement and the distance. Displacement and the distance. Here we just want to distinguish, I'm sure you are very familiar with this from your high school times. Distance just refers to the length of the path taken, during motion. Distance refers to the length of the path taken during motion. So let us give an example. If you have a person starting from the origin and moving moving 70 meters to the right and then moves 30 meters again to the left. What is the total distance that has been covered? We say that distance is the length of the path. It means that the total distance will be 70
plus 30, which gives you 100. So the distance is 100. Now, what is the displacement that has been covered? Now, displacement is basically just the difference between the final position and the initial position. So when calculating the displacement, you just say final position minus the initial position. So you can see that what is the final position? Final position is 70 minus 30, okay, which is 40. What is the initial position? The initial position is 0. So final 40 minus 0 just gives you 40. So now you must also indicate the direction, since you know that displacement is a vector quantity. So you must also indicate the direction. So we say that the displacement is 40 meters to the east. The displacement is 40 meters to the east. So maybe before I go to the next slide, let me go to the comments so that we see what is happening there. Okay, so practical example for coordinate access needed. I think I've already given those practical examples in my explanation. So the other one, amazing to see what I don't understand that. So Daniel, to me, I'm learning well. Thank you very much. Sama Mkuka well explained. Thank you very much for that. The other person is saying not, but when he enlarges the screen. Okay. When I want to scribble something on the screen, unfortunately, I can only do that when I'm not in presentation mode. So that is the challenge that I have. When I need to scribble something, I can't do that in presentation mode. So, okay, so someone is saying that kindly repeat on distance. So distance is the length of the path taken, whereas displacement is just the difference between the final position and the initial position. Okay, so I've repeated. We are going to do an example. So let us now go to the example. Okay, let's go to the example. Okay, so for instance, you have an object. Let us say that you have an object that moves from position. The initial position is x1. The final position is x2. Okay, the initial position, you can see is the initial position is 10 meters. The final position is 30 meters. So what is the displacement that has been made by such an object? So as we have said, displacement is basically calculated by final position minus initial position. So the final position is 30. You can see final position is 30. So if you put it here, and then the initial position, which is 10, you put it here, you find the difference. Then you find that the difference is 20 meters. Now this 20 meters, as you can see, it is a positive number. It is a positive number. So what does it mean? It means that the displacement is to the right. So in short, we are saying that this object has made a displacement of 20 meters to the right. Why are we saying to the right? Because the number is positive. Okay. On the other hand, let us assume that you have this person, which is, I'm just calling the object. So if you have this person moving to the left, initially they are at the position of 30 meters. Finally, they come to the position of 10 meters. So what is the displacement that has been made? As usual, we say, the data, x1 is equal to 30, x1 is the initial, x2 is equal to 10, you see x2 is the final. So from the formula, displacement is always calculated as final position minus initial position. So when you put in these numbers here, which you can do on your own, you find that the answer will be minus 20 meters. Now, what is the significance of this minus here? What is the significance of this minus? It means that the person is actually moving in the negative, along the negative x-axis, meaning that the person is moving to the left. And that is why we have a minus. So very, very important point here. The point is that in one dimension, if you have motion in one dimension, okay, displacements of vector quantities can be represented as scalar quantities with the only difference of the sign. When the sign is positive, it means that the motion is taking place or in the direction of the positive axis. If the displacement, you find a negative. It means that the displacement is in the direction of the negative coordinate axis. Okay, so before I move, maybe let me just check upon you guys in the comments. Let me check. Repeat on displacement. I think I've already done that. So we have to do that now in our spare time. So someone has asked a very good question, asked her to say that where is the direction in the answer? So the direction, as I've explained and I'll explain again, the direction is indicated by the negative or the positive. Since we are in one dimension, the direction is indicated by the, if you have a positive answer, then the direction is to the right. If you have a negative answer, then the direction is to the left. Okay, so I hope that I have answered that one. So someone, Maria, Imaria Amwashi, well explained. Thank you very much. Someone is saying that I don't understand. Kindly repeat. That question is not very valid because I don't know what you have not understood. It may mean that you have not understood everything from the time we started, which will be very difficult for me to do. So someone is saying, well, explain, sir, but send us some tutorial sheets. I'll do that as soon as possible. In terms of direction, so when east, okay, that one has already gone, well explained. Thank you very much. So let us go to something else. Let us go to something else. Vector quantities and scalar quantities, I'll consider this as a revision from your high school work. So you know that vector quantities are quantities which only have, let me start with the scalar quantities. Scalar quantities, they only have magnitude. They only have magnitude. You cannot talk about the direction. Okay, so scalar quantities are quantities such as speed. When we talk about speed, it has got no direction associated. You cannot speak of any direction associated with that. So it is just a scalar quantity. Temperature is just a scalar quantity. Mass is a scalar quantity because you cannot say the mass of an object is 10 kg in this particular direction. Then it doesn't make any sense. On the other hand, vector quantities are those quantities that have got both magnitude and direction associated with them. You cannot speak of just the magnitude for such quantities. For instance, if you talk about velocity, maybe let me start with displacement. Displacement must always have a direction associated with it. As we could see from the previous, slides, when we talked about the displacement, we either said the displacement is 20 meters to the right or the displacement is 20 meters to the left. So when we say to the right, meaning that you are giving a direction. Okay, so and then we say that if you say to the right, it means that the sign must be positive. When you say to the left, the sign must be negative, assuming that the coordinate system that you have chosen is, you have said the right is positive. Okay, let me check if I have any small exercise for you. Let me check if I have any small exercise for you on this, under this, so that we just try to refresh our minds. We have done a lot of talking. So let me just check and see if we have any exercise under this. Okay, so unfortunately, I think I haven't prepared any exercise for you. Maybe I'll do that at a later time, probably in the when we meet for the afternoon session, which will be at 13 hours. So in the meantime, we'll just proceed, and I hope that this point has been driven home about the difference between vector quantities and the scalar quantities. Okay. Now, when you are representing vectors, of course, you use an arrow on top. For instance, if you are talking about velocity, then you put an arrow on top to signify the fact that what you have is a vector. And then this point is what I had been trying to belabor, to say that in one dimension we can drop the arrow, and remember that the positive sign means the vector points to the right, and the negative sign means the vector points to the left. So for instance, here where we say we are talking about the displacement, and we saw that we had a negative sign, so the vector actually points to the left. That is in one dimension. Okay, so as we are trying to wind up, to go for a break, let us talk about average velocity and average speed. Okay, so assume that you are going somewhere. Maybe you are going to you are moving from your room. Assume that you are here on campus, and then you are moving from your room to go from your hostels to go to the lecture theater. Okay, so you are walking, right? So let us assume, of course, there should be some distance between your hostel and the lecture theater. Okay, so as you are moving, maybe along the way you meet a friend, you stop by and chat over things like that, and then you start moving. So your speed will be changing. As you are moving from your room to the lecture theater, your speed will be changing. And of course, as you are doing that, the time will also be lapsing. So if you talk about at the end of the day, when you reach the lecture theater, you can speak about the average speed. The average speed, of course, you have not maintained the same speed. You were changing the speed from time to time, but then you can talk about the average speed as the total distance that has been covered over the total time that has been taken. Okay, so then you calculate the average speed. So the average speed will just give you an idea of what speed you were moving on average, but it does not represent the speed at each and every given point. Are we together? So average speed is given by the total distance covered over the total time taken, and you must keep in mind that along the course, during the course of the motion, the speed could have been changing, okay, but then we are only interested in the average. Okay, on the other hand, now average speed is a scalar quantity, as we have already seen. Now what about average velocity? Average velocity is given by the displacement. What is the displacement that has been taken, and then over the total time. Okay, so now let us say that when going to the lecture theater, you had meandered, you went to see a friend to pick maybe to pick a calculator at your friend's room, and you went somewhere else. Okay, so when calculating the displacement, as we had already seen in the previous slides, you only consider what was the initial position and what is the final position. So you subtract final minus initial. Okay, so if you do that, then you get the displacement that has been made, and then what is the total time that has been taken. So one thing to note is that for velocity, since it is a vector, both magnitude and direction must be given, because you know a displacement is a vector. But then speed, since speed is only a scalar, what you just need is the magnitude. Of course, you know that the units, both for speed and velocity, will be the units of distance over the units of time, which will be meter per second. Let us go back to an example. Let us go back to an example and try to see how we can work out that particular example. Okay, so let us say that you have, say that you have that person. You remember that person who moved 70 meters to the right, followed by 30 meters to the left. We had agreed that there, what is the distance? The total distance that is covered is just 70 plus 30, which is 100. Whereas the displacement that has been covered is only 40 meters. So when calculating the average speed, if we assume that this motion has taken place within 70 seconds, then the average speed will be 100, which is the distance, 100 meters, which is the distance, over 70 seconds, which is the time. You calculate it to be 1.4 meters per second. On the other hand, the average velocity is the displacement, which is 40 meters, as you can see, over the time that has been taken, which is 70 seconds. So you can see from this slide that the same object could cover a different speed and a different, could move at a different speed and yet also at a different velocity. When you talk about velocity, you are only talking about, we are saying it's the displacement over the time taken. The other point to note here is that this number here, it's not complete. You must indicate the direction. What is the direction taken? The direction is to the right. And hence you can see that this is positive. So it is positive because you see that the direction of the velocity is to the right. Okay. So I think this one has, I'll skip this slide, has already been explained sufficiently. Let us just look at another example to illustrate how to calculate velocity. So this example, you have a person running. You see this person running from the position of 50 meters to the position of 30.5 meters. So the initial position is 50 meters. The final position is 30.5 meters. And if we are given that this motion is within 3 seconds, then what is the displacement? Remember displacement, how we calculated it. We said that displacement is the final minus initial. Now, since the final is a smaller number than the initial, you calculate, you find that you have a negative number. Try to do it on your calculator, you find that you have a negative number. So the displacement is negative, which is of course making sense because you can see that this person is moving to the left. Okay, so when calculating the average velocity, we are just going to say average velocity is just equal to the displacement, which we have already calculated as the minus 19.5 meters over the time that has elapsed, which is 3 seconds. So you find that the average velocity is minus 6.5. I'm interested in this negative sign on the answer. So the negative sign means that the velocity, the direction of the velocity is to the left. The direction of the velocity is in the negative x-axis. All right, so I think, ladies and gentlemen, we let us break off at this particular point. So here we have started covering kinematics. We have described certain concepts. We have discussed certain concepts such as the frame of reference. We say that motion should always be measured with reference to a certain frame of reference. So depending on the frame of reference where you are measuring motion, you could have different results. Okay, and then we have also explored the concepts such as speed, distance and displacement. We say that displacement is a vector quantity. Distance is just a scalar quantity. Distance is the length of the path that has been taken, where displacement is just the difference between the difference between the final position of the object and the initial position of the object. We have also discussed speed and velocity, average speed and average velocity. We say that velocity is just the displacement over time, whereas speed is the distance over time. Velocity is a vector quantity because it always has the direction associated with it. When specifying velocity, always make sure that you specify the direction associated with it. So with that, maybe I can just end by checking you guys on the comments. What you guys are, just try to check on the comments. Try to check on the comments. Okay, so I think people have just started chatting. I will not allow this. So someone, why does speed not have direction? Why does speed not have direction? Because that is the nature. It is a scalar quantity, so it doesn't have direction. So are we having the quiz tomorrow? Yes, keep an ear to the ground. We may be having the quiz tomorrow. Someone is saying, I'm now following. Well explained, sir. Thank you very much for that. Can speed be negative? Speed can never be negative because it is not a vector quantity. So someone well explained, sir. Thank you very much for that. Is there a retake on the Moodle? Yes, Moodle always allows the retakes. Someone says, can speed be negative? I've already answered that question. When are we having the tutorial sessions? You'll be advised very shortly. Do we have to know calculus? In this course, you don't need to know calculus. Because the course will be treated in a non-calculus based manner. Okay, what if the direction was in the circular motion? We'll come to that. That's a very interesting thing, Daniel. We'll come to circular motion, we'll discuss that. Okay, is displacement the only vector quantity? There are a lot of vector quantities. When we come back in the afternoon session, I think I'm going to give you a simple interactive quiz where we are going to just try to interact and see the different vector quantities that we have and so on. Okay, so ladies and gentlemen, I thank you for being a good class. And then I'll see you at 13 hours. The next session will be at 13 hours sharp. So we start so that we recover some of the time that we lost during the morning session. Thank you very much for your patience and for your participation in the class. Enjoy your lunch.